So let's start. Welcome. I hope you enjoy your lunch. Have a great afternoon, or it's the start of the night, like here in Germany. I want to show you our latest product we create in the Spring ecosystem at Neo4j. We, as a Spring Data Neo4j OGM team, that is Michael Simons and me. So we both are the SDN OGM team. If you see us in the community, in the Neo4j discourse, you might expect that we are a bunch of people, but they're not just the two of us. So please be kind to us that we do not have so much time for you at any time of the day. So the title is Spring Data Neo4j RX. That stands for Reactive. And first I thought we speak about what is Reactive in a really comprehensive way. Reactive, if you hear Reactive, most of the time people tell or try to promise you that you get a real performance boost when you're doing reactive work. But that's not in general the case. But in contrast to just having an async communication, it allows you to control the data flow. For example, you have something called back pressure. That means your client can say to the server in a simple scenario, hey, you give me so much data, please stop or wait for a specific amount of time before I can handle any more data. But it comes somehow with a little bit of performance boost. You can do more with less resources. So imagine you're working in a, for example, memory restricted environment. You can say, I will want to load all the data I can process right now in memory and then the next ones. And this in an asynchronous way. So you can utilize all your resources in a good way. So when we're speaking about reactive, we could look at the libraries, for example, in the Java universe, like the reactive streams library. That's more or less a de facto standard API for stream processing, for asynchronous stream processing that has support for back pressure and is, of course, non-blocking by its asynchronous nature. So the advantage we have with this API is that we have a contract. And we can then implement against this contract. For example, like the superb Neo4j Java driver team did. And they implemented, or they provide us with one type of this API, the publisher. This is the only type from the Reactive Streams library that is exposed by the driver teams. A publisher is something like it publishes data, yeah. You can imagine there's a publisher and a subscriber then in your application code. So you do not have to care how to generate the data. You only have to care, and we see this later, how to consume this data. And like I said, the reactive streams are only an API. They are pretty much all flavors of implementations. If you would like to work with Ecker or Vertex in a more niche, of Java universe, you go for this, for their implementations, or more general purpose like RX Java or Project Reactor. So the decision were to made, what do we want to use? First of all, in the Java driver, and then later in the Spring Data Neo4j RX project. And it boiled down to Project Reactor. Because we had some experience with Project Reactor, we advised also the drivers team to use it for the Neo4j Java driver. So as it's developed by Pivotal, or now at Pivotal, It has an excellent integration in the Spring ecosystem. It's not tied to the ecosystem, so you can use Project Reactor if you want to work with reactive streams in your applications without Spring. But also, if you have it in Spring project, you have support, or even more support when using Project Reactor, like the data types, sorry, or conversion. So, like I said, the slide before, we have the publisher or publisher implementations, and they come in two flavors in the Project Reactor library. So we have a mono with 0 or 1 element, or a flux with 0 or n elements. These are types you would usually like to consume when you later write a client application that gets data from a publisher. So your publisher would be something like a mono or the flux. So working with reactive streams, or in this example, explicitly with Project Reactor, looks some kind, if you're experienced with Java streams or with the Java Stream API in general, the same. So we generate a little bit of example data. We can then say, well, we want to skip some data. Then later on, we want to manipulate the data, map it, then filter it. So this looks really, really like the Stream API. But we have features like not only take an amount of data out of the stream, but take it for this time, for this duration. So this means that you can say, I do not want to process any data that comes later. So, and just to visualize the things, I can do such things like do on each. We will look on this in detail a little bit, short bit. I want to print out hello. If I then run this program, I can see nothing. That's because this is the very same programming model we also have in the Java driver. This stream is so-called a code stream. They are hot streams, means that they are publishing data on their own. And this so-called code stream needs something like a subscription. So just for the brevity of this example, I added the subscribe function with the system out. And then you can see the output is something on the first so-called signal in the Project Reactor world. We get a hello, then the value, again, hello value. And you can see the very last line of the output is the hello again. So we do not only get this for every element, if we call this do on each, but we get for every signal. And there are additional signals not only for the data you get, but also for the control stream. So there is, for example, on complete signal. That means that the publisher, in this example, the flux, tells the consumer, I'm done, and now I do not have any data anymore. That's important if you want to control your data flow. So keeping this aside for now, we want to look at Spring Data. What is Spring Data? If you haven't heard of Spring Data, I give you a short introduction. So Spring Data is a more module family in the Spring universe. So there are Spring Data modules, for example, for JPA, for JDBC, if you like to have more WAR data access, or for example, for MongoDB. Of course, there's also Spring Data Neo4j right now out there. So we have this consistent programming model. So every Spring Data store or module to 80% behaves the same way like the other one. So we have this abstraction of the data access. You do not tell your driver to execute a query, get raw data from the database, convert it, but you have some kind of object mapping in the Spring Data libraries. And Spring Data was came released with the idea of DDD first, so domain-driven design first. That means if you look at your aggregates or aggregate root, I do not want to introduce DDD right now, and you want to access the data, you go through a repository to access it. So there are other ways to access the data in Spring Data projects, but the favorized way is to go through these repositories. And okay, it's a Spring Data project. It has Spring in its name, so it has seamless integration with Spring ecosystem. That's not very. That's also important for Spring Boot applications. I think everybody who creates Spring applications nowadays uses Spring Boot, but also it can benefit. Every Spring Data project can benefit from the Spring Data core project and then the whole Spring framework. Sorry. So what have we done before? So just to give you a brief history, we have this Neo4j, so-called Neo4j object graph mapper, Neo4j OGM, or even shorter OGM. This does all the heavy lifting. So we have a library that can, by its name, map objects to and from the graph. It cares about the connection to the database. That can be an embedded boat or HTTP connection. But it also has some kind of caching in it, conversion support, everything you need to persist your data to the database. So we have these three connection modes, like embedded boat, HTTP. They're called drivers. That might be a little bit confusing because we also have the Java driver, and so we favorize the term transport modes. Just to be clear, to have a clear definition of this. On top of this sits Spring Data Neo4j, short SDN. So SDN depends and uses all the methods that are exposed in Neo4j OGM to access the database. So if you want to compare it with, for example, Spring Data JPA, it's like you have a JPA implementation like Hibernate in between your database and your Spring Data module. So, but we have learned from our users that most of them are using using SDN. So there are even some users who do not really know that they're using OGM under the hood. That gives us some problems sometimes to communicate, but the percentage of users we hear from, at least, that are using purely OGM are way below the numbers we get from the SDN users. So now you get a little bit of history of the OGM SDN projects, what SDN is and Reactive is, and we see what we do now for the future. So we created a project called Spring Data Neo4j. And why we created it was more or less out of two things we have seen in OGM that were problematic for us to solve when we wanted to go the way to reactive support that's gonna be in the database. So I think you heard it this today at least once or twice, that Neo4j 4.0 will come with reactive support, and we also knew it and wanted to support reactive and reflected the OGM library if we can, or how much work will it be to get it in there. So, but let's see. So first of all, we have this customs class scanning in OGM. That's not a big pain point in this case, but if we would create a library in the Spring universe, we have the Spring Data Core or Commons library I told you before that we can make use of, and it has superb support for this. So why should I manually write code or maintain code that is already rewritten and maintained and well maintained because it lives for years in the library and gets better and better if I don't have to. So, and the other problem, it was more the biggest problem we had, was that OGM, by its very nature, did a lot of caching. So when data came or comes from the database into, let's split things here, into the Neo4j OGM layer of your application, it first of all put all data in the cache. So you have all data in the cache, it fills up, and only after it ends, it gets filled up, you get all the data written back to your application. So the problem here is that we cannot just stream the data. We have to wait for this caching model to fill up. And this was when we spoke about this and discussed in the team. That was something of a pain point for us that we could not just resolve. So we were thinking about creating something like an SDN Lite, etc., that does not all this heavy lifting and caching. But we got the chance to create Spring Data Neo4j. So what did we came up with? So like I said before, it's a combination of the current SDN and OGM, but settled in the Spring ecosystem. So it's more exclusive in the Spring world, but we can benefit of a lot of features and functionalities in Spring Framework and Spring Data Commons. We thought for us that we do not want to have these OGM drivers anymore. We want to work like most of the Spring Data modules, besides Spring Data JPA, as I told you before in the example. So we do not want to have a mapping library in between the Spring Data library and the database. We just want to work on the raw drivers level. So for now, if not in the future, the driver will support more connection or transport modes. We are bold only, but that's good for us because we don't have to translate our communication anymore. We can just consume and make use of the type support in the driver, and do not need to figure out, does this data object come from the database or does it come from the driver? Does it come from the driver, or does it come from, for example, an HTTP connection? There are just missing information for us for the type informations to map them. So that's good for us. Again, less code to maintain. And what was important for us, because it was one of the biggest problems we had when we were thinking about reactive support in OGM, was, of course, that we want to support all the reactive functionality that will come in the database and that we will get through the driver. And as a side effect, but also with a strong focus, we wanted to support the immutability of objects. So that's one other problem we had when we were looking at the caching model, that we could not really decide which objects to combine at which time to produce a really immutable object. So with this key cornerstones, we were on the good way. But then we were looking at an architecture. So for now, just look at the left part of the slides. Sorry. We have a pretty modular concept of accessing data. I told you before, we access through the driver the database. And above this, we have a Neo4j client. That's some kind of a raw connection to the database where you can provide Cypher queries and a mapping function to create your own objects. On top of this Neo4j client, We then will have a Neo4j template. This template is aware of the entities you register in your Spring Data application. So you do not have to provide the mapping function manually, but you will get some kind of automatically conversion for your objects. And using this are the then so-called repositories. So you will see it in a bit in an example. If you have a repository, it will use the template and only the template. This template will use the client and only the client to then use the driver to access the database. That's a pretty clean approach, and we are really really good with it right now. So looking at the right side of your slides, you can see the Spring Boot starter. I will introduce them in a bit. Just wait for it. So what do we have right now in SDN-RX? So of course we have node modeling in there, and we have the relationship support. So we have all the built-in functionality, like the quad functionality that is provided by every Spring Data module implemented. Also, the derived finder methods, we will also see them, and custom sci-fi annotated methods. So if you cannot work with the sci-fi generating parts of your Spring Data, of our Spring Data implementations, you can also provide, you have the chance to provide your manual cipher statements. And we have conversions and the Neo4j type system in there. So we can store everything natively in the database that is a supported type of Neo4j. And since Neo4j 3.4, for example, also the geospatial types and dates, durations, etc. We have support for projections in there, and we also support the upcoming Spring Framework 5.2 Reactive Transaction Manager. So there will be a new transaction manager for reactive transactions. We, besides some other Spring Data modules, are the first who support them. So I think I have enough time to show you the example here. So just to get a feeling how SDN-RX looks like, or if you're still, if you're yet an experienced developer in SDN, you can see the difference. So I have a person that acted in a movie. If I want to describe a person, it looks pretty much the same like it did before in SDN. So I mark my class with a node entity. Now in SDN, it's the node entity, and I define the field for the ID. For example, here we do have a user-created ID, not a generated one for the name. That's pretty much easy. The person acted in a movie, and we thought we keep the annotations like they were in OGM if they fit, like the relationship annotation, and the same attributes like the type and direction. So in this example, we just turned around the relationship. So we do not say a person has an outgoing relationship to the movie, but the movie has an incoming relationship from the person. So we can find better names in the Java universe, for example, like actors. And that's pretty much it. So take a look for more. It's a movie entity. If we want to access the data, we use these repositories I was speaking about. So in my example here, I extend the Reactive Neo4j repository. So everything I say about support for reactive data access, it's also true for the imperative data access. So we still, of course, supporting the imperative programming model. And for example, I want to return a movie. Let's say our movie title that's unique. in this example, and I want to return 0 or 1, like I told you in the beginning. That's it. That's the content of a mono movies. And then Spring Data Neo4j or Spring Data Neo4j RX in this example will create a cipher statement that looks pretty much like this. Because we have the relationships defined as a movie entity, you will get even longer query that also fetches the defined relationships. But we can then compare it on this screen a little bit better. So we query for a movie entity in the Java world that gets translated to the movie label. And we have this keywords find one by that tells Spring Data to create a where clause. By title, okay, it must be the property title on the movie entity class. And then we just additionally add the variable or the parameter to the query, return it. So this can be done out of the box right now with Spring Data Neo4j RX. Of course, even more can be done with it, but that's the so-called derived finder method here. So we derive the query for you. Writing code for entities is great. Having code for accessing the entities is great. Even better is if you have tests. So, for example, like I said in the beginning, we have a publisher that is a movie repository find one by title. So it returns a mono. And then we subscribe on it. And if I subscribe, I have access. I make this, first of all, I make the stream a hot stream. I have access to the data and I can do my assertions. That's great. Everything's green. But just to be sure, I inserted this fail here. So it must fail because it will assert everything and then fail. It's a JUnit, simple JUnit test. Looks good. It's not good. So we do not want, we won't get any time to the fail because even though we subscribe, we do not wait. So we just instruct the publisher to subscribe if a signal comes in, but we cannot wait. And that's another key point for us to use Project Reactor because it has an excellent support for tests. We can wrap more or less all the same we did with the so-called step verifier. And that is also important for you if you use Spring Data Neo4j RX or any other reactive library and work with publishers or in special Project Reactor. So we create the step verifier around this. It's provided by Project Reactor tests and can then finalize, say, verify complete. So we have all the assertion chain. Every assert will get triggered, and the verify complete makes sure that the stream or the signals ends. And we have a green test. It's super great. If you want to get everything in your controller, for example, without a service right now, in this example, it's pretty easy. You inject the movie repository. In the easiest case, you return just the data from the database right back to the users. You can see it in the last method here. So skimming ahead, we saw the Spring Boot starters. If you're a Java driver user right now, you can make use of the newly released Java driver Spring Boot starter for 1.7. It will support the 3.x databases. It creates you a driver bean. You will get all the access to all the driver properties through the application properties, so you do not have to configure everything in code, but can make use of your application properties you have with your Spring Boot application. It supports out of the box, what creates out of the box a health endpoint. If you want to use the beta versions of the Spring of the Neo4j Java Spring Boot starter, you also, for the 4.0 series, you also get a micrometer support, the micrometer support. So it will also plug in and give you more insights to your data, to your database and your application. These are one library we extracted while developing Spring Data Neo4j. That's why I'm talking about this. And we also extracted, of course, more or less, the Spring Boot starter for Neo4j, for Spring Data Neo4j. So from its very nature, it depends on the other Spring Boot starter I just showed you, and it will create this Neo4j client beans that are sitting on the previously created driver bean and the Neo4j template bean. Or if you want to go the reactive way, the reactive Neo4j client and reactive Neo4j template. Keep in mind that you should be focused on one programming model within your application. From a technical point of view, it might work to have both worlds in one application, but it's better to concentrate either reactive or imperative. And the Spring Boot starter also instantiates the user-defined repositories, like the movie repository you've just seen. So you don't have any work to do besides the configuration of the Java driver to access your database with Spring Data Neo4j. So our future plans are a roughly estimated 1.0 in early 2020. So we thought we release it after the database, so we are sure we support everything that is in the database we want to support, and not release a version that might get problems with a patch release of the 4.0 series or an earlier bug fix that comes up with the 4.0. So it might be problematic for us to release. So we wait after the release of the 4.0 series. We have some features missing. So relationships with properties are still a work in progress. We need to finalize the Neo4j template, and like every good developer project with two people, we need to focus on the documentation. If you want to get started today, or if you're like in my time zone, and today is over in a few hours, tomorrow you can see a bunch of resources here. You will find them in the video. Maybe we publish the slides, I don't know yet. So we have the project access, we have an introduction post and video. We have also a blog post about the current state of Neo4j OGM and what we plan to do in the future with it. And there are also guides for all the Java related stuff I just mentioned on our developer pages. Thank you very much. If you have any questions right now, ask them. The other ones can take part in the Hunger Games. Here are the questions. I hope you can read them and have fun. Yes.